I know you'll ask about it. I'll do this problem here, and we're just gonna get started here. This is equations 1, 2, and 3. Okay, and I'm going to go ahead and say that we're going to eliminate x. So if I can simplify and get rid of x, maybe let's multiply this second equation by -1. That'll cancel our x's. So over here, I'm going to say x minus 3y plus z equals 13. And then negative x, if I'm distributing the negative, minus 2y plus 3z equals positive 1. That cancels. This gives me a negative 5y. That's a positive 4z, and that's equal to 14. I can't simplify that at all, but I'm going to call that equation 4. Okay. Now, this is a 2x. I need to use either the first or the third. And with the 13 looming, I'm going to just deal with adjusting the second equation here. And instead, I'm going to multiply this equation here by a -2. This time a -2 because I want that to become a -2, which will cancel with that. So -2x minus 4y plus 6z is equal to positive 2. Okay, I'm going to take this equation down underneath. 2x minus y minus 2z equals 2. And if I combine those together, that goes away. This gives me a negative 5y plus 4z is equal to 4. Well, I see something's about to happen here. That 5y and the negative 5y, this is my equation 5, by the way. If I multiply this by a -1, that's going to cancel with that. And let's look and see what happens. Negative 5y, this is equation 4, plus 4z equals 14. Okay. If I take equation 5 and I've changed the sign by distributing a negative, I got a positive 5y minus 4z equals -4. When I combine those together, not only does that cancel, but so does this. I end up with 0 equals 10. And I know it's got zeros involved, but that's a non-true statement, which means I have no solution. Okay, if it was 0 equals 0, then I'd have many solutions, but that's not the case here.